Welcome to today's lecture and Introduction to Manufacturing. Today's topic is robotics. When talking about manufacturing, we would be amiss not to mention that robotics is a big part of doing what we're doing in manufacturing. Robotics takes the labor out of it. It takes puts in a robot or a machine to do a labor work, usually when it's something that's repetitive, something that it's in a very unpleasant place to be. So to understand robotics, we're going to go over some terms, and we're going to talk about a lot of safety today in our introduction to robotics. You have to start with knowing a definition of robotics. A definition is a multifunctional piece of equipment that is programmed to perform tasks with great acuity. That means that it can do it over and over and over, very precise, without a lot of trouble. It can do it over and over without having to stop and do it very precise each time. Robotics can be used to move a variety of parts, tools, materials, etc. through several specific motions. It means that they can be programmed in. They can do that repetitively over and over and over. Robots are usually used to perform tasks that are unsafe and located in a hazard location. They're very highly repetitive. It means that you may have to do them 100 times an hour. Instead of having a human out there doing that, a robot can do that and keep them safe. Or maybe they're just in a very unpleasant location, very dusty, hot, cold, however the case may be. Robots don't mind those unpleasant locations. Robots have many different functions, such as material handling, assembly of products and subassemblies, welding, perfect example of being in an unpleasant location, as well as doing one over and over and over. Spraying applications, whether it's paint or other type of spraying item. And then machine loading and unloading functions. Continuing on robotic terms, you'll have robots typically, or mostly times, they're 6-axis robots, which means they have 6 joints. Each one of them has a pivot point for movement. That means that it's kind of like our arms. Our arms only have a few pivot points. Robots have a few more so that they can make sure they can do the job that's asked. And they have components that are such as called the trunk, the shoulder, the upper arm, the elbow, the forearm, and the wrist, and even the base. And those are very similar. I mean, you can assume the upper arm is kind of similar to our upper arm. The elbow is similar to our elbow. The forearm is kind of our elbow, and then the wrist, it's kind of the same thing. So when you hear the term articulated robot, you know that it has joints, usually the 6-axis joint type, and those are the names for them there. The base is a stationary platform on which the robot is mounted. Robots typically are asked or required to pick up heavy loads and move them from one place to another. So in order to do that, you have to be on a firm foundation or a very good base in order to do that. So the base probably needs to be mounted to the ground and attached a little bit so that you can see that. There's a video that's attached to this. It's kind of an elementary robot, but it kind of gets the point across. You'll see there that the robot has a pretty decent sized base and for it to do its work on it. So you can see it. The end effector, which is the device at the end of the robot arm that actually does the work. It's actually the one that interacts with the environment. On the video that's attached, it has a little gripper. The gripper is just used for grasping and holding, attached to the free end of the arm, and it is a type of end effector. There are some other ones, maybe a welder at the end of it. There may be a hook or anything else that you may want to do on the end of it. The term joint, as you know, we've talked about it before. The joint in connection with one segment of an articulated robot to the next, which is also segmented to the base. It's a pivotal point of a segment. And then payload. And maximum payload is the amount of weight carried by the robot manipulator and reduced speed while maintaining a rate of precision. Payload is like we talked about in hydraulics and pneumatics, the maximum load of the system. So if you have a hydraulic system and you may say, what's the maximum load? It's a 300 psi system. Well, the same thing goes with a robot. What is the load of the robot? Well, it's a 2,000 pound, it's a 1-ton unit. Means that that's the smallest mechanism, rated mechanism of that robot is 1 ton. You wouldn't want to, it can't pick up any more. It probably could, but you'd be worried about breaking a piece. Safety factors built in, those kind of things. So understand that what a payload is when it comes to robots. So when you're dealing with robots, robots can be can cause a lot of injury. So you want to make sure that you understand robotic safety. Most robotic accidents and injuries occur during programming and test runs because people are freely moving within and out of the robot while they're programming it to get it to do what it's supposed to do. You're fine-tuning it, trying to dial it in, and sometimes carelessness or just human error gets in the way and people get hurt. Also happens during tool change and setup and inspection of work. People are usually kind of getting in the area, kind of getting in the way. The robot doesn't really know you're there, and therefore it is doing its job, and therefore injury can kind of happen because it is doing its job, but it doesn't know you're there. Robotic accidents and injuries can be caused by human error, which is the #1 case. If you know what the robot's doing, he knows what it's doing, so it's your place to get out of the way because he doesn't know that you're there, or the robot doesn't know that you're there. Mechanical hazards, yes, mechanical things are going to break. They're going to have problems. Maybe a power source problem with whether it's electrical, hydraulic, pneumatic, those type things could give you a problem. And then of course environmental hazards. Maybe there's too much heat, too much dust. One of those things can cause the robot to have accidents causing. The attached video talks about the work envelope. There is 3 different types of work envelope. You have the maximum work envelope, which is the total area in which the robot is capable of reaching out and touching you, I should say, with all the end effectors and everything else fully extended, is its maximum envelope. The restricted envelope is the area in which the robot is capable of moving with the installation of hardware and software. And then you have the operating envelope, which is the envelope in which the robot doing its daily chores or daily task is going to be doing, not within its restricted or without, outside of its maximum, just right there in front of it. What is it doing unless something should happen? So it's very important to know the 3 different work environments. And I always have you an exit route because just because it's working in its work environment and you're in its restricted envelope, something could happen, or in its maximum envelope, something could break and it could go haywire and causing injuries. Some more hazards when dealing with robotics. Mechanical hazards such as pinch points. Robot movements, you want to be out of the way of those. You want to make sure you're not pinched or trapped. Power source, electrical, robot motor brakes, and then others. There's hydraulic, pneumatic, even a water type source sometimes can be used for for robots. Then there's environmental hazards. Robots can release parts, so you never want to be underneath one of those. Robots can have sharp objects and or moving sharp objects. And then of course the cables, the hydraulic cables, the pneumatic cables, whatever, hoses and tubings, whatever the case may be, can cause slipping and tripping hazards. And then if there's any spills, make sure you clean those up right away. And then of course distractions. A lot of times robots are gee whiz. You walk into an area, wow, look at that, that's pretty neat, pretty cool. And then all of a sudden, bam, that robot has reached out and touched you and hurt you pretty bad. Sometimes it's environmental. You're working in a noisy situation. Manufacturing atmospheres are not quiet in most cases, and of course you have to pay attention. Of course, also when you're dealing with robots, being around robots, sometimes you have to take your external world and set it aside for a second so I can do my job at hand, do it, and then come back to what I'm doing and be able to relax a little bit and kind of keep in mind what you're doing. So there's a few robotic safety devices that can help. A physical safety barrier or gates or fences can be used to keep humans out of that area. Emergency stops can allow an operator to completely shut down the power to the robot in case of an emergency. Interlocks. Interlocks are used to sense that the robot has satisfied the required conditions and can go back to the work sequence so that if something should happen, such as a emergency work stop button has been hit, in order for it to come back on, the operator and the robot have both determined that everything has met its conditions. The interlock is engaged, and therefore the robot can go back to doing its work. Sometimes those interlocks have to be done when light curtains are broke. Light curtains are infrared beams that communicate with transmitters that stop movement. They're kind of like the James Bond or the Mission Impossible things you see when people are trying to break in to steal the crystal globe at the end of the hall. When the light beams are broke, the equipment shuts down so that it doesn't affect anybody. Safety mats are positioned around the robot so that if for some reason something or somebody should walk up to it, it senses the weight and it automatically shuts the robots down so that it doesn't reach out and touch somebody unexpectedly. Other indicators are visual indicators, audio indicators, and then motion sensors. If it detects a motion in the area, they automatically shut down. In a lot of cases, in very highly mechanized manufacturing locations, they're going to use a series of several of them. You may have a safety mat, a motion sensor, definitely emergency stops, physical safety barriers, and interlocks. All those provide extra safe in case one of those should fail from doing its job. So that kind of what will happen the case. But anyhow, keep in mind robotic safety. Accidents are inevitable, or are not inevitable, I should say. They all can be avoided. Mainly, like we mentioned earlier, there are human errors. So if you keep engaged of what you're doing, understand what's going on, know what that robot can and can't do, and understand the hazards that are there, you're going to be safe. The person that is most responsible for the safety for yourself is you. Whether it's you're working around the robot or just driving down the road. If you're driving down the road, who's most responsible for your safety while you're in your car? You are. So keep that in mind. It doesn't matter, if you're in an environmental setting with robots or an environmental setting in your car, driving down the road, listen to your AC/DC tunes. Still, the most person responsible is yourself. So keep that in mind. Remember these safety guidelines. Always comply with safety procedures of the company. Maybe it's OSHA, maybe it's just standard operating procedures, but make sure you know what they are and comply with them. Be familiar with the robotic actions. Never take chances. I'm going to run in there real quick while the robot's on the other side. I know it's about to go. Nope, something bad's going to happen. Just don't do it. Injuries and accidents aren't worth that much. Stay focused on safety. Stay focused. As we mentioned earlier, sometimes put what's going on in your mind or what's going on at home or in your personal life, put those aside so you can stay focused while you're dealing with robots. And then also, always plan an escape route. If you're inside of one of those work envelopes, I always know that, okay, I need a way out if something should happen. So know and plan accordingly. So check out the video on the different types of work envelopes. The information we've covered today is enough to get you through your quiz at the end. And good luck, and I'll see you